So we talked about measures of center. For this next hour or so, it's time to talk about measures of spread. How to know approximately how wide that curve has become. Well, our first measure of spread that we're going to discuss is called the range. Now, our last measure of center that we discussed was the mid-range. And the range is related to that. In the mid-range, we took the maximum and added the minimum to it and divided by 2. For the range as a measure of spread, we're just going to take the maximum and subtract the minimum. Now, I have 2 data sets over here. For set A, to find the range, what's the maximum? What's the largest number in that set? 31. What's the minimum? So that gives me a range of 24. For set B, what's the maximum? 31. What's the minimum? 7. Gives me a range of 24. So according to the range, both of those data sets are equally spread out. I would argue that that is not true, though. If I were to put these numbers on dot plots, I'm going to put A on the top of this. So I've got 7 right there, 13, 19, 25, and 31. That's set A. Set B, I'm going to put in blue. I've got 7, 16, 19, 22, and 31. Which would you say is less spread out? The red or the blue dots? The blue is definitely tighter together. I mean, there's the 2 that stick way out there, but the ones in the middle are tighter together. They have the same range, but the red ones are kind of evenly spread out across the whole range, where the blue ones are tighter in the middle and just a couple out on the end. So it is less spread out. The range cannot distinguish between those sets. So the range is not a good measure of spread. So we use something called the variance and the standard deviation. The formula for variance or standard deviation, they are slightly different. Depends on whether we're looking at a population or a sample. If it's a population, the standard deviation has a symbol that looks like that. That is the small Greek letter sigma. It is equal to the square root of the sum of each of the numbers, x minus the mean for that set of numbers, then squared, then divided by, n is just how many, capital N is just the number of items in a population. But now we said before that we very, very rarely have a complete population. Generally what we're doing is we're using a sample to estimate the population. So if we have a sample, the standard deviation is abbreviated with just the letter S, the small letter s. And it is found by taking the square root of each number minus the mean, then squared and adding those all up, then dividing by, now here's the difference. Remember, little n is the size of a sample, and we subtract 1 from it. Now, at this point, I suspect many of you are looking at those formulas and thinking, well, so let's take a look. Let's break this down step by step. I don't expect you to be able to look at that formula and be able to calculate a standard deviation. There are several steps involved. It's a 6-step process. So we're going to start out with that first set of numbers. 7, 13, 19, 26, and 31. Step 1 in finding our standard deviation is to find the mean. So if I take 7 plus 13 plus 19 plus 26 plus 31, I get 95. Divided by 5 is 19. That's my mean. Step 2 is to subtract the mean from each number. So I'm going to write up my numbers 7, 13, 19, 26, and 31. And from each number, I'm going to subtract my mean of 19. What is 7 minus 19? Negative 12. 13 minus 19. Negative 6. 19 minus 19 is 0. 26 minus 19? That right down there, it should be 25. That would be why that doesn't look right. Yeah, that number should be a 25. Come on, scroll. This should be a 25. So 25 minus 19 would be 6. 31 minus 19 would be 12. That set of numbers right there is referred to as the deviations. Sometimes called the deviations from the mean. That's what it is. That's how far each number is away from the mean. Step 3. It's to square each deviation. So when you do this on your calculator, be careful. Remember, a negative number, when you square it, has to go in parentheses. It has to give a positive result. Negative 12 squared better be a positive 144. Negative 6 squared is 36. 0 squared, I'll give you a 0. 6 squared, 36. And 12 squared, 144. Those are referred to as the squared deviations. Makes sense? You just took the deviations and you squared them. Step 4. is to find the sum. So if I add those numbers up, that comes out to be 360. That number I just found there is referred to as the sum of the squared deviations. Really creative with their names here, huh? Yeah. Out of paper. So sum of the squared deviation. Step 5 is the tricky one. Step 5, we're going to divide by n minus 1. Now for this set of data, what did n equal? 5. There were 5 numbers in the list. So that meant that n minus 1 was 4, right? So we're going to divide by n minus 1. So we're going to divide by 4 equals 90. This result here, after we divide, is called the variance. Now I said it was a 6-step process. We are now at step 6. Yeah. Square root. So it's the square root of 90. Now, a lot of people screw this up, the difference between squared and square root. Squaring, you're multiplying it by itself. Usually you're getting larger if it's a number bigger than 1. Square root, you're reversing that. You're getting this, if it's bigger than 1, you're getting a smaller number. So you do second squared, this gives you the square root symbol, of 90 should give us 9.49. That number we just got there is the standard deviation. The standard deviation measures the average distance that numbers are from the mean of the data set. So on average, the numbers are 9.49 away from the mean. Now our other data set was 7, oops, come on, the scrolling is working wonderfully here too. 7, 16, 19, 23, and 31. 22 and 31. Sorry. I'll give you a hint. The first step is to find the mean. In your notes, I'm going to give you a few minutes. Try to find the standard deviation of that. So the mean is 19. What's step 2? Subtract the mean from each. So we've got the 7, 16, 19, 22, and 31. And we will be subtracting 19. 7 minus 19, 16 minus 19, negative 3. 19 minus 19, 0. 22 minus 19 is 3. And 31 minus 19 is 12. Step 3. We're going to square them, right? Those are the deviations. Now we're going to square them. So our first squared deviation is negative 12 squared, which is positive 144. Negative 3 squared, 9. 0 squared, 0, 3 squared, 9 and 12 squared, 144. That's the squared deviations. Step 4 is to find the sum of the squared deviations. Correct. Which is what, 306? That is the sum of the squared deviations. Step 5. Perfect. You divide by n minus 1, so n is 5, so we're going to divide by 4. So that is what, 76.5? Now remember, that is what is referred to as the variance. To find the standard deviation, we need to square root of 76.5, which is 8.75. That's our standard deviation. Now that is smaller than our previous answer of 9.49. So those numbers are less spread out. So those are our measures of spread. Now there's some other numbers in here called measures of position. And our measures of position come up often enough that it's nice to know what they're talking about. Measures of position. We're going to talk about percentiles first of all. A percentile tells what percent of all items are less than this item. So if you have kids, or if you're younger, you might remember doing it yourself, taking a standardized test and being told you are in the 86th percentile. What that means is you scored better than 86% of all the people who took the test, or 86% of the people scored worse than you. However you want to look at it. Now, I'm going to make a set of numbers. One of the first steps dealing with percentiles is to put them in order, just like with medians. My list of numbers here is already going to be put in order, just to save a bunch of time. One, two, three, four, five, 6, 7, 8, 9, 10. Oh, let's go with 11. So there's my set of numbers. What does n equal here? Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n is 11. If I am asked to find a certain percentile, find the 80th percentile. Step one is going to be to put them in order, just like it was for the median. They're already in order. Step two is going to be to find that position, just like we did for the median. Let's do that now. The median, we did 1/2 or 0.5 times n to find the position. The 1/2 was because it has to be in the middle. Half of the data is smaller than it, half is larger. Here, how much of the data is going to be smaller? 80th percentile means 80%. That is 0.8 or 0.80 times 11 times n. That is 0.88. Sorry, that's wrong. That is 8.8. That's what we get. Since that is a decimal, what do? Round up. Even if it was 8.2, we would still round up to the 9th position. So then step 3 is to find the 80th percentile, which is in the 9th position here. That's the 34. So the 80th percentile in this set of data is the 34. Now this is a small set of data, only 11 numbers. Because of that, you look confused. Okay. Because of that, because it's a small set of data, there are some little quirks as we're finding these things. Like if I were to ask you to find the 75th percentile. Well, they're already in order, so we're just going to go for the position here. What are we going to multiply? 0.75 times 11 is n. So that's going to give us, what, 8.5. Well, it's still going to round up to 9. So that the 75th percentile is still 34. And again, the reason that's happening is because there's only 11 numbers in the list. That 34 is actually like from the 74th all the way up to the 82nd percentile, just because there's only a few numbers there. What if I ask you to find the 35th percentile? I'll have you try that one on your own. How do you find the position?
Multiply
0.35 times 11, which is 3.85. Of course, that is going to round up to 4. The 4th spot is the 24. Did you figure it out, Joey? Okay. So finding a certain percentile isn't horribly challenging. The biggest thing you got to, actually, to be honest, the place that I see most students make the mistakes here is putting them in order. They miss a number when they go to put them in order from smallest to largest or something like that. or they write down a number twice or whatever. So the biggest thing I can recommend there is count them before you put them in order, and after you put them in order, make sure you have the same number of items there. I'm going to look at one more set of numbers here. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here, I put them in order again already, from smallest to largest. That part's done. Yeah, I do. I ask you to find the 25th percentile. Well, they're already in order, so I'm just going to go for the position, which is going to be found by doing what? 0.25 times 12, which is 3. Now, when we did the median, if this came out to be a whole number, what did that mean? Yes, it's between that position and the next one. So it'll be between the third and the fourth position. So our third position is 19. The fourth position is 21. We have to add them together and divide by 2. So the 20, the 25th percentile is 20. Notice it's not one of the numbers, it's between two of the numbers. Now, another type of question we can run into is, what percentile is a certain number? Well, the percentile of a number is found by taking the number that are smaller than that number plus half of the number that are equal divided by the total, divided by n. And then, of course, we're going to have to move the decimal to make it a percent. So what percentile is 38? So for 38, how many are smaller than the 38? 9. How many are equal to the 38? 1. How many total are there? 12. So on top we've got 9 plus 1/2 times 1. 1/2 times 1 is 1/2. 9 plus 1/2 is 9.5 over 12. So 9.5 divided by 12. It's 0.7916. 0.7917. We are going to move the decimal point to make that a percent. 79.1, or we'll call it just the 79th percentile. And you know, fine for me, what percentile is 21? How many are smaller than the 21? 3. How many are equal to the 21? 1. And of course, n is still 12. So 1/2 times 1 is still a half. 3 plus 1/2 is 3.5. So we have 3.5 divided by 12. 0.2917. Which we're going to just leave it as the 29th percentile. I'll give you a shot at redemption. Find what percentile the 24 is. The 24. The 24. Does it affect us? Exactly. So there are 4 numbers smaller than 24. There are 2 numbers equal to 24. That's why it doesn't matter which one, because they're both equal to 24. So there's 2 of them equal. So 1/2 times 2 is just 1. 4 plus 1 is 5. So it's 5 over 12, which is 0.4167. So we're going to call that the 42nd percentile. Any questions? So if you ever deal with standardized testing, or deal with kids, they'll say your weight or your height or your head circumference or whatever is in a certain percentile for their age. That's what all that means. Now, when we talk about data analysis and statistics, there's something that's slightly more useful than percentiles, and that is quartiles. Quartiles cut the data into quarters. Divide the data into 4 equal pieces. Now, by 4 equal pieces, I mean 4 pieces that have the same number of items in them, not necessarily the same range. Might have put an extra number in here. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nope, 11, 12. I got 12 numbers here. So n equals 12. Now again, for quartiles even, Generally, we'd be looking at a much larger set of data with a lot more numbers in it. But to keep it handy for us, easy for us, we're going to be looking at 12. Now, if I had a piece of string or a board or whatever, and I wanted to cut it into 4 equal pieces, how many cuts do I have to make? 3 cuts, right? I cut 3 cuts will give me 4 pieces. So quartiles are cutting the data into 4 pieces, but I only need 3 cuts. I only need 3 quartiles, 1, 2, and 3. The first quartile is equal to the 25th percentile. So all I'm going to do for position is take 0.25 times my n of 12, which is 3, which means it's between 3rd and 4th. So that's going to be the 23 and the 24. So, or sorry, 23 and 25. So 23 plus 25 divided by 2 gives me 24. That's my first quartile. The second quartile, anybody want to guess? 50th percentile. You got it. Usually I do an example of the 50th percentile. I didn't this time. But what am I going to do to find the position of the 50th percentile? 0.5 times 12. Anything else that we did that was 0.5 times n? Median. The 50th percentile and the second quartile are just the median. So since that is the 6th number, it's between, or it comes out to 6, it's between the 6th and 7th number. So it's between 28 and 31. So 28 plus 31 divided by 2 is 29.5. That's our median or second quartile. The third quartile is the 75th percentile and will be found by doing, perfect, 0.75 times 12, which is 9. So that's going to be between the 10th, 9th and 10th. So yes, 37 and 42, which is 39.5. So the quartiles, usually we refer to them as the first quartile, the third quartile, and the median instead of the second quartile. They make up most of what is called the 5-number summary. The 5-number summary is the minimum, the first quartile, the median or the second quartile, the third quartile, and the maximum. So for this set of data, The minimum was 11. You're froze? Okay. Oops, I didn't have the recording right. So we have the median, the minimum, first quartile, median, third quartile, and max we got from those numbers. We can use this on the same axis we would do a dot plot. Say 10, 15, 20, 25, 30, 35, 40, and I'm not going to make it with that. Let's try that again. Okay, so we can mark these out on here. We have the minimum of 11, first quartile of 24. I want to mark that first quartile with a slight line that goes up and down like that instead of just a dot. The median is 29.5 right here. Third quartile is 39.5. And the maximum is 53. So I'm going to put a dot at the maximum. Notice the first quartile, the first, second, and third quartiles are marked with those little lines. That's because I'm going to connect the tops of those lines like this. That's called a box. Real technical term there. Then there's whiskers that come out from that box to the minimum and the maximum. That's called a box and whisker plot. Depending on the textbook, some textbooks just called a box plot. But what it does for us is it shows us where the data is spread out and where it's close together. Each section of this plot, this piece here, this piece here, this piece here, and this piece here, is 1/4 of our numbers. So since there's n equals 12, each of those sections is 3 numbers. So you can see right here, since this piece is much smaller than the others, those numbers must be packed together tighter there. This is the largest piece up here. Those numbers must be spread out the most there. So what this plot tells us is where the numbers are packed tighter together and where they're more spread out. So we have 3 box and whisker plots, or 3 box plots. Which one would you expect to be the bell curve, the normal curve? The top one. Because the numbers are tightly packed together in the middle here, right? So that we'd expect that center box to be smaller. This is saying the numbers are most tightly packed together on the outside. That would actually look something like that. And this one, of course, would be skewed like that. The smaller the section of the box plot, the higher that distribution is, the more numbers are packed in there. Okay, I think you guys have suffered enough for one day. There is a new quiz today that is due tonight at 11:59 p.m. Actually, you know what? I'm going to double check and make sure there's a new quiz. There is? Okay. There is a new homework. Of course, due for Monday. This will be your last homework on Monday. You okay? Hurt yourself? On Monday, we will cover new material. But my math lab does not have homework on this new material. So we'll talk about it on Monday, but there won't be any new homework. I don't know if there's a new quiz Monday or not. But we're getting really close. Tuesday next week will be a review day. So Tuesday of next week is going to be totally dedicated to going over the last 2.5 weeks worth of material to get you guys ready for the test on Thursday. No, it's covering pretty much just the last 3 weeks.
Oh, really?
Yeah.
Oh, God. Seriously.
And you will have the whole hour. Well, there was supposed to be a cumulative final test on the last day, but I took our last unit test, which was supposed to be next Tuesday, and I moved it back because I thought we needed one more day of review before we took it. You guys seem to be struggling a little bit with the geometry and the graphing, so I figured rather than cramming in an extra test, we're going to take a day to go back over that stuff for a day. The volumes and surface area? Yeah. Well, it's like we said, that's that visualization ability that develops when you're young. And if you didn't develop it, you've got to learn how to cope with it. You can never develop it once you get past the age of 10 or 11. So it's a matter of figuring out, okay, now that I don't have that visualization ability, how do I do this type of stuff without being able to visualize it?
I was really surprised